So in numbers 4 through 6, we're going to determine the best name for each parallelogram and find the values of all variables. Okay, so in number 4, the things that I see in this picture, we have that all sides are congruent and we have a right angle. I know that all sides are congruent only in a square and a rhombus. And the rhombuses don't have right angles, so that means that this has to be a square. Okay, so because it's a square, that's going to let me solve for C, because C is one of the corners, so C is 90 degrees. We also know that in squares, diagonals bisect angles, which, since this is a diagonal, that means that E is half of 90 and D is half of 90. So E is 45 degrees and D is 45 degrees. All right, okay, so in the next one, I'm not going to assume anything about the sides. My sides aren't marked congruent, so I'm going to assume that they're not. And I have a right angle. So that means that this guy is going to be a rectangle. I know in rectangles that the diagonals bisect each other and that they're congruent, which means that all of these pieces right here are congruent, which is actually a very important property that we can use for a lot of solving. Is that what that means is that all these little pieces right here, like this little triangle, that's an isosceles triangle. And that's going to be helpful because we know that in isosceles triangles, the base angles are congruent to each other. So keep that in mind. We'll use that in a little bit. Okay, so go ahead and, using what we've talked about, go ahead and pause and see if you can solve for H, G, F, and K on your own, and then we'll check it together in 1 second. Okay, so the first thing that I solved for was F. So since I know that this thing up here is an isosceles triangle, that means that the angle where F is and the other part of the isosceles triangle, the other base angle, have to be congruent. So in that whole triangle, I've already used up 110 degrees. So 180 minus 110 equals 70. So half of that is 35. So that means that F has to be 35 degrees, and this other little angle also has to be 35 degrees. So once I knew that, it helped me solve for K, because I knew that the 35 degree angle plus K have to add to 90 together. So 90 minus 35 is 55. So I have 55 degrees left for K. Which means this guy right here, this little angle, is also 55 degrees because we have another isosceles triangle right here. So those base angles have to be congruent to each other. So now in my purple triangle, G plus 55 should equal 180 because all triangles have 180 degrees. So G is 70. You also could have found G because you could have said, okay, well, I know that these angles right here make a linear pair, and so 180 minus 110 equals 70. That could have been another option. But we could use that to find H because we know that H and G make a linear pair, so they should add to 180. So that means that h is 110. You also could have said that h and the other 110 are vertical angles, and so that's how you could have solved for h too. So you have several options on this one. And let's look at number 6. So number 6, I have that all my sides are congruent. I'm not told anything about if these angles are right angles or not, and so I'm not going to assume that they are. Even if they look like it, I'm not going to assume that they're right angles unless I'm told they're right angles. So that means that I only have enough information to say that this is a rhombus. Okay, so in a rhombus, we know that diagonals make right angles, which means that C is 90 degrees. And that means I can solve for B, because if this guy's 90 and this guy's 39, then everything in that triangle on the upper right should add to 180 degrees together. So 90 plus 39 plus B equals 180. Which means B is 51. Which means I can also solve for A, because in a rhombus, diagonals bisect angles. So A and B should be congruent. So A is also 51 degrees. And last but not least, I need to solve for X. So I'm noticing that this is a right triangle. I have the hypotenuse is 25, I have one leg is 7, and so I'm going to use Pythagorean theorem to solve for x. So 25 squared equals 7 squared plus x squared. So if you solve that out, x is 24. Okay, so now that you guys have had some practice with me, I'm going to let you guys try 7, 8, and 9 with your group. So you can work on it on your own for a little bit, but then definitely check with your group and help each other out. So go ahead and pause the video, maybe take 7 or 8 minutes or until it seems like almost everybody is finished, and you can unpause it, and then I'll run through it with you real quick. Okay, so now that you've unpaused the video, hopefully everybody has done most of them, so I'm just going to run through these with you just super quick. Okay, so if ABCD is a rectangle, so when we name quadrilaterals, by the way, we go in vertices, like we're not going to go A, B, C, D and skip around. So instead of doing that, we're going to go like around the clock almost. So A to B to C to D. So AB is 2x plus 14, CD is 4x minus 12, AD is 9. We want to find the length of AB and the length of AC. So first of all, since these guys are congruent, I know that BC is also 9, so I just like to fill in missing information. I also know that AB and DC are congruent, so I can say 2x plus 14 equals 4x minus 12. When you solve for x, you get x equals 13. And when you plug back in, you get that AB equals 40. And so then if you're solving for AC, well, AC is a diagonal, so you can use Pythagorean theorem to solve for AC. So using Pythagorean theorem, you get that AC equals 41. Okay. WXYZ is a rhombus with diagonals meeting at M. So I'm going to draw my best rhombus here. I hope that you drew pictures for these too. It's WXYZ. Draw in my diagonals meeting at M. Let's see, so WM is 3x plus 7. And YM is 5x minus 3, And we know that diagonals bisect each other in a rhombus. So 3x plus 7 equals 5x minus 3, so x is 5. So if we're going to find wy, you can just plug 5 back in and get, let's see, 3 times 5 plus 7 is 5 times 5 minus 3. Let's see. So I got 44 for wy. And last piece, JKLM is a square with diagonals meeting at R. MJR is x squared minus 4x. And we want to find x. Well, in a square, diagonals bisect opposite angles, and angles are 90, which means that this angle should also be 45 degrees. So x squared minus 4x equals 45. So again, you're going to factor. Hopefully when you factored, you got x minus 9 and x plus 5, which means that x equals 9 or negative 5. When you plug those back in, both of those give you good possible solutions, and so you have 2 possible solutions for x. All right, okay, so the only other thing that I have for you guys to do today is some practice, which you also picked up. So what you can do is you can, when you turn on this video, you can take a little mental break. Go ahead and keep your phones away, but you can talk to your friends, stand up, walk around the room, say hi to someone. Keep your phones away for now though. Take a little break, and then I want you guys to do the practice. So you can work with each other. I'm going to have the keys printed out at the front of the classroom. When you're ready to check them, you can pop up and do that. But talk to each other, get some good practice in. Keep your chart in front of you of properties that you can work on those. And then when you're finished with the practice, then you can get your phones back out and have the rest of class for free time. All right. Be sure that you come to advisory or tutorials if you guys need any help. Have a good day.